Okay, so when we solve linear inequalities, we solve them by graphing. And here's an example to begin with. We're going to graph the inequality 3x plus 2y is less than 2. And I'm going to put this in y equals mx plus b form so it's easy to graph. And that means I'm going to have 2y is less than negative 3x plus 2. And y is less than negative 3/2 x plus 1. Okay, this means that my y-intercept is 1 and my slope is negative 3/2. So I'm going to put a point at 0, 1. And then I'm going to go down 3 over 2. Okay, I'll do another point just to make sure. Okay, now y is not equal to this. It's less than this. Since it's not equal, then I'm going to do a dashed line through my points. Okay, and then I'm going to shade whichever side of this line makes this a true statement. So pick a point on one side of the line. I'm going to pick 0, 0 because that's an easy one to work with. And we're going to ask ourselves, is 0 less than negative 3/2 times 0 plus 1? And the answer is yes, 0 is less than 1. That means that anything on this side of the line, the same side that 0, 0 is on, will be a solution to this inequality. So now we're going to apply that process to a system of inequalities. Okay, so now I have 2, and I'm going to solve the top one, then I'm going to solve the bottom one, and wherever the shading overlaps for both of them, that will be our solution set. So here we go. Y is greater than or equal to negative x minus 2. Okay, so that means that my y-intercept is at negative 2, and my slope is negative 1. So I'm going to go down 1 over 1, down 1 over 1, and so on. Now, since y is less than or equal to, that means that I'm going to draw a solid line, okay? Kind of sloppy, but there, woof. Okay, now, y is less than negative x plus 2. So I'm going to go to positive 2 for my y-intercept. And once again, my slope is negative 1. But remember that since y is not equal to, it's going to be a dotted line. Okay, same slope. Okay, so shading. All right, this first one we'll do in yellow. So y is greater than negative x minus 2. So ask yourself, let's pick the point 0, 0, because it's easy to plug in. Is 0 greater than negative 0 minus 2? Yes, it is. 0 is greater than negative 2. So everything above our first inequality, and then I'll do the second one in green, we'll put in 0, 0 again. Is 0 less than 0 plus 2? Yes, 0 is less than 2. So everything below our second line, that means that our solution set is where they overlap, which means it's everything in between. That's the solution to this system of inequalities. Okay, so let's do this system of inequalities, and it's already in mx plus b form. So y is greater than 1x plus 1. So I've got a y-intercept at 1 and a slope of positive 1. So I'm going to go up 1 over 1, up 1 over 1, and so on and so on. So it's doing this. Oh, I made a mistake. Y'all see what I did? Y is greater than, not equal to. So that means I'm going to make this dashed using my eraser tool, which is handy in this case. Okay, so that takes care of that one. Okay, y is less than x minus 1. So that means I have a y-intercept at negative 1. And once again, the slope is positive. And I'm going to remember to do dashed right here. Okay, so let's put in, just to be different, I've been doing 0, 0 a lot. So let's put in 0, 5 for the first one. So is 5 greater than 0 plus 1? Yes, it is. So that means we're going to shade everything above our first line. Okay, and then let's put in, let's put in 4, 0. So is 0 less than 4 minus 1? Yes, it is. So now we will shade everything on the same side that 4, 0 is on. Well, does the shading for either one overlap at all? No, it doesn't. So there is no solution to this system of equations. And finally, we don't have to be limited to just 2 inequalities in a system. We can graph as many as we want. So let's do this. We have y is less than or equal to x. So that's this one right here, and it's a solid line. And y is less than or equal to x. So I'll pick 0, negative 2. Is negative 2 less than or equal to 0? Yes, it is. So we'll shade everything below that one. And how about y greater than or equal to negative x? Okay, so here's y is greater than or equal to negative x. And it's everything greater than that. So pick, say, 0, 5 for a test point. Is 5 greater than or equal to 0? Yes, it is. So we're going to shade everything above that one. And finally, y is less than 3. So that's a horizontal line. And y is everything below that. And so that is everything in here. And continuing out here, so it looks like it's this area right here is our solution set to this system.